Welcome to the session on graphs and transformations, sketching graphs. The objectives for this session are to sketch quintic, quadratic and reciprocal graphs and highlight important coordinates on the graph, and sketch two graphs on the same axes and find points of intersection. A cubic function is of the form f of x equals ax cubed plus bx squared plus cx plus d, where a, b, c and d are real numbers. The graph can take different forms depending on the values of the coefficients. If q is a root of the function, then the graph crosses the x-axis at q0. Let's now take a look at some cubic function examples. In the two examples highlighted, a is greater than 0. And in these two, a is less than 0. Let's now take a look at an example. Pause the video and have a go. Press play when you're ready to view the solutions. So let's solve example 1a. We are required to sketch the function y equals x plus 3 times x minus 1 times x minus 2, indicating the points where the function crosses the axes. So when y equals 0, either x equals minus 3, or x equals 1, or x equals 2. And when x equals 0, y equals 6. That's 3 times minus 1 times minus 2. Also, as x tends to infinity, in other words towards the right-hand side, x plus 3 tends to infinity. Also, x minus 1 tends to infinity, and x minus 2 tends to infinity. So when the three are multiplied by each other, f of x, or y, also tends to infinity. As x tends to minus infinity, x plus 3 tends to minus infinity, x minus 1 tends to minus infinity, and x minus 2 tends to minus infinity. So when the three are multiplied by each other, we have that f of x, or y, also tends to minus infinity. So as x tends to minus infinity, f of x tends to minus infinity also. And so let's incorporate these facts into our graph. And once we've joined the points, incorporating the facts, the graph should look something like this. Now let's solve example 1b. We are required to sketch the function y equals x times x minus 1 times x plus 2, indicating the points where the function crosses the axes. So let's plot this. When y equals 0, x equals minus 2, or x equals 0, or x equals 1. Also, when x equals 0, y equals 0 also. As x tends to infinity, x minus 1 and x plus 2 all tend to infinity, and therefore f of x tends to infinity too. As x tends to minus infinity, x minus 1 and x plus 2 all tend to minus infinity also. Therefore, when we multiply them by each other, f of x tends to minus infinity too. So as x tends to minus infinity, f of x tends to minus infinity. And so when we plot our graph incorporating these points, the graph should look something like this. Now let's have a go at another example. Pause the video and have a go. Press play when you're ready to view the solutions. Now let's solve example 2a. We are required to sketch the function y equals x plus 1 all squared times x minus 1, indicating the points where the function crosses the axes. So let's solve this. When y equals 0, x equals minus 1, or x equals 1. And when x equals 0, y equals minus 1. As x tends to infinity, x plus 1 all squared tends to infinity, and so does x minus 1. And therefore f of x tends to infinity too. As x tends to minus infinity, x plus 1 all squared tends to infinity, and x minus 1 tends to minus infinity. So when we multiply a positive number by a negative number, we obtain a negative number, and therefore f of x tends to minus infinity. So when we sketch the graph incorporating these points, it should look something like this. Notice that at the point where x equals minus 1 and y equals 0, we have a double repeated root. This is because we have x plus 1 squared in the equation, and therefore the graph simply touches the x-axis. And now for example 2b. We are required to sketch y equals 2 minus x all cubed, indicating the points where the function crosses the axes. So let's try sketching this. When y equals 0, x equals 2. And when x equals 0, y equals 8. As x tends to infinity, each part, or 2 minus x, tends to minus infinity. So when we cube 2 minus x, we have that f of x tends to minus infinity too. So as x tends to infinity, f of x tends to minus infinity. And when x tends to minus infinity, we have that 2 minus x tends to infinity, so when we cube, we obtain that f of x tends to infinity. So as x tends to minus infinity, f of x tends to infinity. And therefore, if we sketch the graph, it should look something like this. Notice that we have a triple repeated root here, so this is a point of inflection as shown. Now let's have a go at example 3. Pause the video and have a go. Press play when you're ready to view the solutions. So let's solve this. We are required to sketch the function y equals x minus 2 times x squared plus x plus 3. So when y equals 0, x equals 2, or x squared plus x plus 3 equals 0. However, x squared plus x plus 3 does not have any real roots, as b squared minus 4ac is negative. Also, we have that when x equals 0, y equals minus 6. Let's go through the process again. So let's explore what's happening as x tends to infinity. We have x minus 2 tends to infinity, and this quadratic also tends to infinity. So f of x, or y, tends to infinity too. Also, as x tends to minus infinity, x minus 2 tends to minus infinity, and x squared plus x plus 3 tends to infinity. Now you might be thinking, why is that? Because x squared tends to infinity, but x tends to minus infinity. However, quantitatively, as x squared is larger, it's increasing towards infinity at a much larger rate than x is decreasing towards minus infinity. So x squared numerically is superseding the x. So overall, the impact is that x squared plus x plus 3 tends to infinity. And therefore, when we multiply, so x minus 2 times this quadratic, we have that f of x tends to minus infinity. And so if we incorporate these points and we sketch our graph, we should obtain something like this. However, we do need to add something here. There is not enough information to know the exact shape of the graph, and it could be shaped something like the one shown on the right-hand side of the screen. Let's now take a look at quartic functions. A quartic function is of the form ax to the power 4 plus bx cubed plus cx squared plus dx plus e, where a, b, c, d and e are real numbers. The graph can take different forms depending on the values of the coefficients. If q is a root of the function, then the graph crosses the x-axis at q0. So let's have a look at some examples. In the two examples highlighted, a is greater than 0, and in this one, a is less than 0. Notice that the third graph has distinct roots and a repeated root here. Now let's take a look at an example. Pause the video and have a go. Press play when you're ready to view the solutions. So let's solve example 4a. We are required to sketch the function y equals x plus 2 times x plus 3 times x minus 1 times x minus 2, indicating the points where the function crosses the axes. So when y equals 0, x equals minus 3, or x equals minus 2, or x equals 1, or x equals 2. And when x equals 0, y equals 12. We've simply multiplied 2 by 3 by minus 1 by minus 2. Also, as x tends to infinity, all the different parts tend to infinity, and therefore when we multiply them together, we have f of x tending to infinity also. As x tends to minus infinity, the different parts tend to minus infinity. Now, as we're multiplying four negative numbers by each other, we have that f of x tends to infinity. So as x tends to minus infinity, f of x tends to infinity. And the graph will be shaped like this. And now for the solution to example 4b. We are required to sketch the function x times x minus 1 squared times 2 minus x. So when y equals 0, we have that either x equals 0, or 1, or 2. Also when x equals 0, y equals 0. As x tends to infinity, x minus 1 all squared tends to infinity, but 2 minus x tends to minus infinity. So when we multiply positive times a negative, we get a negative. So f of x, or y, tends to minus infinity as x tends to infinity. Now as x tends to minus infinity, we have x tending to minus infinity, x minus 1 all squared tending to infinity, and 2 minus x tending to plus infinity. So when we multiply the three by each other, we obtain that f of x tends to minus infinity. So as x tends to minus infinity, f of x tends to minus infinity also. So incorporating these points, we should obtain a graph looking something like this. Notice that we have a double repeated root here because we have x minus 1 squared. So now let's solve example 4c. We are required to sketch y equals x minus 1 all squared times x plus 2 all squared, indicating the points where the function crosses the axes. So when y equals 0, x can equal minus 2, or x can equal 1. And when x equals 0, y equals 4, because we're multiplying minus 1 times minus 1 by 2 times 2. Also, as x tends to infinity, x minus 1 all squared tends to infinity, and x plus 2 all squared tends to infinity too. And therefore f of x tends to infinity. Also, as x tends to minus infinity, x minus 1 all squared tends to infinity, and x plus 2 all squared tends to infinity. So as a positive number times a positive number is also positive, we have that f of x tends to positive infinity. So incorporating these points, the graph should look something like this. Notice we have a double repeated root at x equals minus 2 because the function has x plus 2 all squared in it. And similarly, we have a double repeated root at x equals 1 because we have x minus 1 all squared in it. Now let's take a look at reciprocal graphs. These are graphs such as 1 over x or minus 1 over x squared or 2 over x, etc. And they can be sketched by considering their asymptotes. The asymptote is where the denominator is equal to 0. So for example, f of x equals 1 over x minus 2 has an asymptote at x equals 2, because this is where the denominator is 0. Let's take a look at some more examples. We have sketched here y equals 2 over x. The function y equals k over x with k greater than 0 has a similar shape. And here we have y equals minus 1 over x, and the function y equals k over x with k less than 0 has a similar shape also. Y equals 3 over x squared has a positive y throughout, and similarly y equals k over x squared with k greater than 0 will have a similar shape. And here's y equals minus 4 over x squared, and y equals k over x squared with k less than 0 will have a similar shape. Now let's take a look at another example. Pause the video and have a go. Press play when you're ready to view the solutions. So let's have a go at example 5a. We are required to sketch on the same diagram y equals 3 over x and y equals 9 over x. So let's sketch these. Here's y equals 3 over x. And here's y equals 9 over x in purple. And now let's have a go at example 5b. We are required to sketch on the same graph y equals minus 1 over x and y equals minus 5 over x. So here's y equals minus 1 over x, and here's y equals minus 5 over x. And now for example 5c. We are required to sketch on the same diagram y equals 5 over x and y equals 10 over x. So here's y equals 5 over x, and here's y equals 10 over x. Now let's take a look at intersecting graphs. Functions can be sketched in order to show points of intersection and solutions to equations. The x-coordinates at the points of intersection of curves with equations y equals f of x and y equals g of x are solutions to f of x equals g of x. So let's take a look at an example. Pause the video and have a go. Press play when you're ready to view the solutions. So let's explore example 6a first. We are required to sketch on the same diagram the curves with equations y equals x times x minus 4 and y equals x squared times 1 minus x. So y equals x times x minus 4 looks something like this. And we can see that the quadratic cuts the x-axis at x equals 0 and x equals 4. And here's y equals x squared times 1 minus x. The cubic cuts the x-axis at x equals 0 and x equals 1. Now a cubic will eventually become steeper than a quadratic, so graphs will intersect for some negative value of x. Part B requires us to find the coordinates of intersections. There are 3 points where the curves intersect in our example. At the intersections, x times x minus 4 is equal to x squared times 1 minus x. So solving this gives us that x equals 0, x equals minus 2, or x equals 2, as shown. Now when x equals 0, we have that y equals x times x minus 4 equals 0. And when x equals minus 2, we have that y is equal to 12. We've simply substituted in one of the equations. And when finally x equals plus 2, substituting x equals plus 2 in the equation, it could be either of the equations, we get y equals minus 4. and therefore the curves intersect at 0, 0, minus 2, 12, and 2, minus 4. Now let's take a look at another example. Pause the video and have a go. Press play when you're ready to view the solutions. So now let's solve example 7a. We are required to sketch on the same diagram the curves with equations y equals x squared times 4x minus a and y equals b over x, where a and b are greater than 0. So here we have y equals x squared times 4x minus a, and notice we have a repeated root at x equals 0, and the x-axis is cut at x equals a over 4, as shown. And here we have y equals b over x. And notice the reciprocal does not cut the x-axis. So let's find the number of real solutions to x squared times 4x minus a minus b over x equals 0. Notice there are two intersection points here. So the sketch shows 2 points of intersection of these two curves. And therefore there are two real roots. Now let's have a go at another example. Pause the video and have a go. Press play when you're ready to view the solutions. So let's sketch these two curves on the same diagram. Here's y equals x squared times x minus 4. We have a repeated root at x equals 0, and we have a root at x equals 4. And now we have y equals 10 over x squared superimposed on this graph. Notice the reciprocal does not cut the x-axis. Now let's solve example 8b. This will be linked to part A. We are required to state the number of real solutions to x to the 4 times x minus 4 minus 10 equals 0. In part A, we produced this sketch. Notice that there is one intersection point of the two graphs. So, x squared times x minus 4 is equal to 10 over x squared at one point. Rearranging this, we have that x to the 4 times x minus 4 minus 10 equals 0. And this is clearly the equation that we have as part of example 8b. And therefore this equation also has one real root. This brings us to the end of this session. If you have understood its contents, you should be able to sketch quintic, quadratic and reciprocal graphs and highlight important coordinates on the graph. You should also be able to sketch two graphs on the same axes and find points of intersection. So this brings us to the end of this topic. If you would like to understand it in greater depth, do attempt the exercises related to it in your textbook. Thank you very much for listening.